Hello there, and welcome to the Sleepy Science Channel. I'm so glad you found your way here tonight. Maybe it's been a long day, or maybe you're someone who likes to drift to sleep with quiet wonder, letting thoughts of distant worlds replace the noise of daily life. There's nothing you need to do now but rest. Let your mind grow still, your breathing slow, and your body light. Because tonight, we're not just closing our eyes, we're traveling into cosmic mysteries, wandering through the soft shadows of the universe where questions linger like distant starlight. From ancient beginnings to strange energies, from dark matter to hidden worlds, we'll explore 100 sleepy facts to help you relax, unwind, and dream of the cosmos. And if these calm explorations help you rest, consider liking and subscribing. It helps other sleepy travelers find their way here too. Now, close your eyes, and let's begin. Fact 1. The Whisper. Before time, long before stars glimmered or galaxies spiraled into being, the universe rested in a state so dense and quiet that even the idea of time had not yet awakened. This moment, if it can be called a moment at all, was a soft, compressed hush, a place where everything that would ever exist was folded gently into a single shimmering point. When expansion began, it wasn't an explosion, but a slow unwrapping, like a deep breath taken after a long, peaceful pause. Space stretched, smoothing itself outward, carrying with it the seed of every atom, every star, every distant dream you've ever had about the night sky. It is humbling to imagine such a beginning. Everything calm, everything waiting, everything possible. And from that quiet beginning, a universe began to bloom. Beyond that first whisper, another mystery soon followed. Fact 2. When space learned to expand. As expansion continued, the universe didn't simply get bigger. It learned how to stretch. Space became like a soft fabric, gently elongating between all points at once. There was no center, no edge, no boundary, only a smooth increase in distance, like a slow drift across an endless ocean. In those early instants, particles danced apart, cooling as they drifted. What would later become galaxies and stars was still only a warm fog of possibilities, moving outward with a rhythm that has never stopped. Even now, billions of years later, the very room you're resting in is expanding, silently, softly, without any sensation at all. Expansion is not loud or forceful. It is tender, patient, and incredibly steady. A quiet unfolding that continues through every moment of our lives. And in that unfolding, an ancient glow began to form. Fact 3. A glow older than stars. As the newborn universe cooled, its light softened into a faint, uniform warmth. A glow so gentle that it still drifts through space today. This is the cosmic microwave background, the oldest light we can see. A dim afterglow from when the universe was only a few 100,000 years old. It is everywhere at once, filling all of space like a warm mist of ancient photons. Scientists study its tiny ripples, which look like soft freckles across the sky, each marking a slightly denser patch of the early cosmos. These small variations would become the galaxies, clusters, and stars that now decorate the night. This glow is a message from the deep past, humming quietly across eternity. And just beyond it, more mysteries waited to take shape. Fact 4. The first atoms drifted free. As the early universe continued to cool, something quietly remarkable happened. The first atoms formed. Tiny protons and electrons, once too hot to stay together, finally found the calm they needed to join hands. Hydrogen came first, the simplest, lightest element, followed by gentle traces of helium. These newborn atoms drifted through an expanding sea, scattered like soft grains of stardust floating in warm twilight. There were no stars yet, no planets, no galaxies. Only a vast, delicate fog of atoms humming through space, waiting patiently for gravity to gather them. In this calm, drifting cloud lay every blueprint for the cosmos to come. And from that drifting fog, the universe began its first patterns. Fact 5. The universe's silent map. Those first atoms didn't spread out perfectly evenly. Some places held just a little more matter than others. Tiny differences, almost impossibly small. Yet these faint variations became the foundation of everything. Where matter gathered slightly thicker, gravity pulled more strongly. Where it was thinner, space stretched more freely. In this way, the earliest structure of the universe quietly took shape. Today, we can see this ancient pattern preserved in the soft freckles of the cosmic microwave background. It's like a map drawn in the language of warmth and coolness, whispering the story of how galaxies and clusters would someday gather. This silent map guided the entire future of the cosmos. And slowly, the next clues emerged in its shadows. Fact 6. The shadows of ancient light. While the earliest light still drifts through space, it carries with it tiny shadows, subtle dips in temperature that reveal the universe's earliest secrets. These shadows aren't dark like night. They're delicate, like faint brush strokes on a glowing canvas. But within them lie the fingerprints of dark matter and the long-vanished conditions of the cosmic dawn. By studying these soft variations, scientists can trace how invisible forces shaped everything we see today. These dim signatures help us understand why galaxies formed where they did, why clusters gather the way they do, and why the universe has its grand, web-like architecture. Even the faintest shadow can tell an ancient story. And beyond these early imprints, the cosmic web itself slowly awakened. Fact 7. The Great Cosmic Web forms. As gravity continued its gentle pull on drifting matter, the universe began to shape itself into a grand and delicate pattern. Over millions of years, tiny clumps grew into long, faint threads, and those threads wove themselves into a vast web stretching across unimaginable distances. This cosmic web became the hidden scaffolding of the universe, a quiet architecture made of galaxies, clusters, and countless stars. Most of the space between these threads remained empty and still, while the filaments themselves became highways of matter slowly gathering and flowing. In this way, the universe learned to structure itself, not through rigid design, but through the soft, persistent tug of gravity. Within these filaments, new stories were waiting to unfold. Fact 8. The mystery of why anything exists. Among all the mysteries of the cosmos, one of the quietest, yet most profound, is this simple question: why does anything exist at all? In the earliest moments of creation, matter and antimatter should have formed in perfect balance, destined to cancel each other out and leave nothing behind. But somehow, a tiny imbalance occurred. For every billion particles of antimatter, there were 1,000,000,001 particles of matter. That last extra bit is what became everything. This slight preference, this almost unnoticed tilt toward existence, remains unexplained. It is as if the universe made a gentle choice in favor of something rather than nothing. A whisper of asymmetry that allowed stars, planets, oceans, and dreams. Because of that small difference, the cosmos has a story to tell. Fact 9. Symmetry. That almost was physicists often described the early universe as striving for a perfect symmetry, a state where forces were unified, particles interchangeable, and everything balanced like a calm, mirrored lake. But as the universe cooled, that symmetry cracked. Forces split apart, particles gained identity, and the neat, elegant balance dissolved into a more complex and varied world. This breaking of symmetry might sound like a loss, but it was the beginning of diversity. The reason we have light and gravity, atoms and galaxies, and the intricate chemistry that makes life possible. In the soft unraveling of symmetry, the universe found room to grow. And from that gentle break, a new balance quietly emerged. Fact 10. A universe balanced on a knife's edge. From the very beginning, the universe expanded at just the right pace, not too fast, not too slow. Had it expanded a little quicker, matter would have thinned out before stars could form. A little slower, and everything would have collapsed back in on itself, falling into a heavy silence before galaxies ever had a chance to bloom. Somehow, the universe found a delicate middle path. This balance is one of the great cosmic puzzles. It's as if the cosmos walked a tightrope stretched across eternity and never once wavered. Every star you see, every world that turns, every breath you take exists because the universe hovered in this perfect equilibrium. And tucked beneath that balance lies something even stranger. Fact 11. The invisible weight. When astronomers first measured how galaxies spin, they noticed something surprising. The stars at the edges moved far faster than they should have. By all normal counts of matter, those galaxies should have flung themselves apart long ago. But something unseen, something with mass but no glow, held them together. This hidden material became known as dark matter. It acts like a quiet gravitational foundation, shaping galaxies from the shadows without ever revealing its form. It doesn't shine, reflect, or warm. It simply pulls, gently yet firmly, anchoring the cosmic structures we see. It is a reminder that much of the universe moves in ways we cannot directly observe. And all around the stars, more invisible hands are at work. Fact 12. Galaxies held by ghostly hands. Dark matter doesn't gather in neat glowing clusters like ordinary stars. Instead, it permeates space in vast halos, enormous, rounded envelopes that cradle each galaxy like a soft, unseen cocoon. These halos act as scaffolding, providing the gravitational strength needed for stars and gas to collect and remain bound over billions of years. Without dark matter, galaxies would be fragile things, easily torn apart by their own motion. With it, they become steady, structured, and long-lived. The stars we see are only the luminous embroidery on top of a deeper, invisible fabric. And within that fabric, the cosmos continues weaving its quiet mysteries. Fact 13. The cosmic glue. Though dark matter remains invisible, its presence is revealed through the way it binds galaxies together like a silent cosmic glue. Stars swirl around galactic centers with remarkable speed, yet they stay held within a stable embrace. This unseen substance forms a gentle, persistent pull that keeps structures from drifting apart, even across millions of light years. In this way, dark matter doesn't shout its existence. It whispers through gravity, shaping the universe without demanding attention. Entire clusters of galaxies move under its influence, orbiting one another in slow, majestic dances. It is the quiet force behind so much cosmic order, and scientists still search for the particles that make up this hidden glue. Fact 14. The search for silent particles. For decades, researchers have been listening for clues to uncover the true identity of dark matter. They build sensitive detectors deep underground, shielded from noise and radiation, hoping to catch the faintest touch of a passing particle. Some experiments look for tiny flashes of light. Others listen for slight vibrations or changes in energy. Yet the particles remain silent, slipping through matter, drifting through planets and stars, passing unnoticed through our own bodies. They behave like gentle ghosts, present everywhere but never fully revealed. Still, scientists persist, guided by curiosity and the belief that even the quietest mysteries can someday speak. And while we search, dark matter continues bending light in unexpected ways. Fact 15. Light that bends around nothing. One of the strangest hints of dark matter's presence comes from the way it bends and warps light. As starlight travels across the universe, it passes through regions filled with invisible mass. Gravity gently curves its path, creating delicate distortions known as gravitational lensing. Sometimes, distant galaxies appear stretched, doubled, or subtly smudged, not because of anything visible, but because of something unseen in the way. It's as if the universe wears an invisible veil, subtly reshaping the light that reaches us. These distortions act like fingerprints, allowing astronomers to trace the hidden structures etched into space. Through these faint curves of light, the cosmos reveals its secret contours. And beyond those curves, more mysteries unfold. Fact 16. The dark halos beyond stars. Every galaxy, including our own Milky Way, sits inside an enormous dark matter halo that stretches far beyond its visible edges. These halos are quiet spheres of unseen mass, expanding outward like soft, transparent shells. Though we can't see them, their gravity shapes the way stars orbit and determines how galaxies grow and merge over time. Within these halos, the luminous parts of galaxies, the stars, gas, and glowing dust, float like tiny islands on a vast, invisible sea. The halo itself may be up to 10 times larger than the galaxy it surrounds, reaching into regions where starlight never travels. This unseen structure holds galaxies steady in the cosmic currents, and even with its guidance, mysteries still linger in the spaces between stars. Fact 17. Cold streams in the void. In the quiet, dark spaces between galaxies, rivers of dark matter are believed to flow gently through the cosmic web. These cold streams move slowly and silently, shaping how galaxies gather material and grow. Though we cannot observe the streams directly, simulations suggest they feed young galaxies like delicate cosmic lifelines, delivering gas and matter across immense distances. These streams may help explain how galaxies form stars over billions of years, receiving a soft, continuous supply of fresh material. They weave through the emptiness like threads of shadow, guiding the evolution of cosmic structures without ever revealing their form. Through these hidden channels, the universe nurtures its creations. And yet, the puzzle of missing mass still deepens the mystery. Fact 18. The puzzle of missing mass. When astronomers measure the total mass of the universe, they discover a curious imbalance. Only a tiny fraction of it is made from the familiar atoms that build stars, planets, and people. Most of the mass, nearly all of it, in fact, is invisible, detectable only through its gravitational pull. This missing mass is one of the longest-standing mysteries in astrophysics. Even on smaller scales, like within galaxies or clusters, the visible matter never accounts for the full gravitational effect observed. Something is always missing, like a quiet presence just beyond our reach. The universe seems to carry more weight than it chooses to show. This gentle discrepancy continues to inspire new theories, new instruments, and new wonder. And beyond it, the dance between light and dark becomes even more intriguing. Fact 19. The dance of dark and bright. Throughout the universe, visible matter and dark matter move together in a slow, graceful partnership. The stars we see trace the deeper currents created by the unseen mass, orbiting within its gentle pull like lanterns drifting along an invisible river. Though one glows and the other remains forever dark, both shape the grand design of galaxies. This quiet dance governs how stars cluster, how galaxies spin, and how massive structures form across billions of years. It's a partnership built not on collision or contact, but on gravity's soft yet steady influence. The luminous and the unseen weave a shared story, one shaping form, the other giving it strength. And beyond this balance of shadow and light, a deeper mystery begins to rise. Fact 20. A universe with more shadow than light. When we look at the cosmos, we find that everything familiar, stars, planets, dust, clouds, makes up only a small sliver of all that exists. Most of the universe is made of things we cannot see. Dark matter, which adds mass, and dark energy, which stretches space itself. In truth, the luminous world we know is like a tiny island surrounded by vast, unknown oceans. This realization changes our perspective. The night sky, as rich and sparkling as it seems, is only a faint hint of the full cosmic tapestry. There's far more shadow than brightness, far more mystery than clarity, yet the universe continues calmly on its path. And within those shadowed expanses, a new force quietly reveals itself. Fact 21. The force that pulls everything apart. In the late 1990s, astronomers discovered something astonishing. Not only is the universe expanding, but the expansion is speeding up. This unexpected acceleration hinted at a mysterious energy permeating all of space, something that pushes galaxies apart with a gentle but relentless pressure. They called it dark energy. Unlike gravity, which gathers things together, dark energy softly encourages everything to drift apart. It acts evenly everywhere, like a quiet breath filling the cosmos. We can't see it or measure it directly, yet its effects shape the destiny of the universe on the largest scales. Dark energy remains one of the deepest enigmas in modern science. And from this unseen force, more mysteries gently unfold. Fact 22. A quiet acceleration. As dark energy gently fills every corner of space, it creates a slow but persistent acceleration that pushes galaxies farther and farther apart. This isn't a sudden or dramatic force. It's subtle, like the faint pull of a distant tide. If you could watch the universe unfold over billions of years, you'd see galaxies drifting away from one another as though carried by an invisible current. This acceleration shapes the future in profound ways. It determines how quickly space grows, how distant galaxies appear, and how the night sky will slowly fade over unimaginable spans of time. Yet it moves with remarkable stillness, a quiet expansion woven into the fabric of reality. And in that gentle outward drift lies a deeper puzzle about the space between. Fact 23. The unknown. Pressure in space. Dark energy is often described as a kind of pressure within empty space, a soft insistence that encourages everything to spread apart. But what exactly causes this pressure remains one of the greatest open questions in physics. It doesn't behave like any known force, nor does it match our usual understanding of emptiness. Instead, it whispers from the background, influencing the universe without revealing its nature. Some theories suggest it could be a property of the vacuum itself, while others imagine fields or energies that hum quietly in the dark. Whatever the cause, dark energy acts everywhere at once, shaping the cosmos with a steady, unseen hand. This unknown pressure helps define the universe's destiny. And as space expands, its distant boundaries grow increasingly mysterious. Fact 24. The fate of an expanding sky. Because of dark energy, the universe's expansion will continue to accelerate far into the future. Over immense stretches of time, galaxies outside our own local group will drift away faster than their light can reach us. The night sky, once filled with countless galaxies, will slowly darken as those distant lights slip beyond our cosmic horizon. Stars will still shine, and new ones will continue to form, but the broader universe will grow quieter and lonelier on the largest scales. It's a peaceful fading, not destructive or sudden, just the slow stretching of space as it follows its natural course. Yet within this expanding sky, countless mysteries remain to be explored, and deep within the fabric of space, more secrets gently stir. Fact 25. The puzzling empty space. Empty space is not truly empty. Even in the quietest vacuum, tiny fluctuations shimmer in and out of existence, particles appearing and vanishing before they can ever be seen. This restless background hum is part of the universe's very fabric, and some scientists believe it may be connected to the mysterious force of dark energy. If these quantum flickers have a cumulative effect, they might create a faint pressure that encourages space to expand. But the numbers don't quite add up, leaving a gentle puzzle at the heart of physics. The vacuum is both peaceful and strangely active, calm yet full of silent possibility. In the stillness between galaxies, this quiet energy continues its soft work. And just beyond those empty stretches lies a horizon we can never truly touch. Fact 26. The horizon we can never reach. Because the universe expands faster and faster, there are distant regions we can never explore. Not with telescopes, not with spacecraft, not even in imagination's farthest reach. This invisible boundary is called the cosmic horizon. Everything beyond it moves away from us faster than light can travel, not by breaking the rules, but because space itself is stretching. It's a gentle reminder of the universe's vastness. No matter how far our curiosity reaches, there will always be places hidden beyond the fading edge of light. Galaxies out there continue to shine, form stars, and drift through their cosmic lives, forever separated from our own sky. This unreachable boundary is not a wall, but a quiet fading, and the light approaching it stretches softly into new colors. Fact 27. Stretching light like silk. As the universe expands, the light traveling through it stretches as well. Wavelengths grow longer, shifting from bright colors into softer, redder tones. Over great distances, this stretching becomes so pronounced that entire galaxies appear dimmer and more distant, as though seen through a veil of gently pulled silk. This effect, known as redshift, helps astronomers measure how far away objects truly are and how quickly space has expanded over time. Every photon carries a record of the journey it has taken, a quiet imprint of distance, motion, and the gentle expansion of the cosmos. Through stretched starlight, we read the universe's history like a whispered tale. And far ahead, another mystery waits in the constancy of change. Fact 28. A constant that may not be constant. For many years, scientists believed that the strength of dark energy, often described through the cosmological constant, never changed. It was thought to be a stable feature of the universe, steady and unshifting, like a quiet heartbeat within space itself. But some theories suggest that this constant might gently evolve, altering its influence over vast stretches of time. If dark energy changes even slightly, the entire fate of the cosmos could shift with it. Perhaps expansion will slow. Perhaps it will accelerate more quickly. Or perhaps it will drift through cycles we cannot yet imagine. We simply don't know. The universe may be whispering its secrets through a constant that quietly moves. And as it moves, distances stretch into futures we can barely trace. Fact 29. A future with ever wider distances. If dark energy continues its work unchanged, galaxies will drift farther and farther apart, their light dimming into the deep background of space. Over trillions of years, the night sky would look emptier, with distant galaxies slipping beyond visibility. Only the closest companions, the ones already bound to our own galaxy, will remain part of our cosmic neighborhood. This widening of the universe won't be sudden or harsh. It will unfold slowly, gently, like a soft tide receding over an endless shore. Stars will continue to form for ages, but the larger cosmic tapestry will grow quieter, more isolated, and more serene. In this distant future, space becomes a calm, expanding ocean, and at the heart of that ocean lies a mystery that always stays a step ahead. Fact 30. The question that outruns us. No matter how much we learn about dark energy, it always seems to stay one mystery ahead. Every discovery answers one question while revealing another. Why does the universe accelerate? What gives dark energy its power? Why does it act evenly across all of space? Each answer drifts just beyond our reach, like a soft light receding into twilight. This evasive quality isn't frustrating, it's humbling. The universe isn't withholding secrets, it's simply vast beyond comprehension, unfolding in ways that require patience, wonder, and quiet reflection. Some mysteries may remain mysteries forever, and that is part of their gentle beauty. And as we ponder these questions, gravity pulls us toward another realm of cosmic intrigue. Fact 31. The silent collapse. Deep in the hearts of massive stars, a quiet tension builds over millions of years. When their fuel runs thin and the delicate balance between pressure and gravity falters, the star collapses inward with incredible force. But from our perspective, across the vast distances of space, the process feels strangely calm, a silent folding of matter into an infinitely dense point. This collapse creates a black hole, a region where gravity becomes so strong that even light can't escape. No sound crosses its threshold, no message returns from within. It is the universe's most serene and private place, a hollow of perfect stillness. And surrounding this silent core lies a boundary where time itself begins to slow. Fact 32. A point where time slows. Near a black hole, gravity is so intense that it bends not only space but time as well. The closer you approach its edge, the event horizon, the slower time seems to pass. To a distant observer, anything falling toward the black hole appears to move in gentle slow motion, stretching into infinity. This slowing isn't an illusion. It's a real effect of warped space-time. Particles, light, and even time itself follow curved paths around the black hole's immense gravity. If you could drift nearby, you would experience moments differently than the rest of the universe, as though the flow of time had softened into a thicker, quieter stream. Just beyond that strange calm lies a threshold no light can cross. Fact 33. The horizon of no return. The event horizon of a black hole is not a surface or a wall. It's a boundary defined only by fate. Once something passes it, the path inward becomes unavoidable. Light that crosses the horizon never returns. Matter that drifts too close moves past it softly, inevitably, as though sliding over the edge of a cosmic waterfall. To an outside observer, nothing ever appears to cross the horizon completely. Objects freeze and fade, their colors stretched into darkness. But from the falling object's own perspective, it drifts across the boundary without any sudden change. The horizon is both peaceful and absolute, quiet yet transformative. And beyond this mysterious edge, black holes continue to shape the galaxies around them. Fact 34. The stars that feed the darkness. Around many black holes, swirling disks of gas and dust form like luminous whirlpools. These materials spiral inward slowly, warmed by friction and stirred by magnetic fields until they glow with incredible brightness. Though a black hole itself emits no light, the matter falling toward it can shine more brilliantly than entire galaxies. This process is not violent from a cosmic distance. It unfolds like a slow, shimmering drift of material spiraling toward an unseen center. As gas draws closer, it stretches into delicate ribbons of light before crossing the threshold where brightness ends and silence begins. These glowing disks reveal the presence of a black hole even when the darkness itself remains hidden. And deeper inside, the black hole's spin begins to shape everything around it. Fact 35. Spins that twist space. Black holes often rotate, carrying enormous angular momentum inherited from the stars that formed them. This spin doesn't just turn the black hole, it twists the space around it. Nearby particles follow curved paths, drawn into swirling motion by the dragging of space-time itself. Even light bends differently when approaching a rapidly spinning black hole. This effect, known as frame dragging, makes the region around a black hole feel like a calm but powerful whirlpool. If you drifted nearby, you would feel space-time subtly urging you to rotate along with it. Nothing escapes this influence. Not gas, not light, not even the fabric of space. The spin shapes the world around the black hole in quiet, elegant ways. And sometimes, these distortions echo faintly across the cosmos. Fact 36. Black hole echoes. When two black holes collide and merge, their combined shape vibrates for a brief moment, creating ripples in space-time known as gravitational waves. These waves travel across the universe like gentle tremors, stretching and compressing space as they pass. When detected on Earth, they arrive as tiny, nearly imperceptible whispers, changes smaller than the width of a proton. After the merger, the newly formed black hole settles into a stable shape, ringing softly like a cosmic bell. Scientists call these faint, final vibrations echoes, though no actual sound travels through space. Instead, the waves carry information about the black hole's mass, spin, and structure. Through these subtle ripples, the universe allows us to listen to its deepest transformations. And, beyond these echoes, more mysteries await in the shadows. Fact 37. A shadow cast without light. When astronomers captured the first image of a black hole, what they saw wasn't the black hole itself, but its shadow, a dark circle surrounded by a glowing ring of light. This shadow forms because the black hole bends and traps any light that drifts too close, creating a silhouette against the swirling brightness of the surrounding gas. The image looks soft and hazy, like a lantern seen through thick fog, yet it reveals profound truths about gravity and space-time. That dark center marks the point where light cannot return, where the world transitions from the knowable to the unknowable. Even without emitting light, the black hole creates a presence that shapes the space around it. And behind that shadow lies a puzzle about what happens to what falls in. Fact 38. Where information hides. One of the most intriguing mysteries of black holes is the question of information. In physics, information refers to the details of particles, their arrangement, their properties, their history. Normally, information cannot be destroyed. But when something crosses a black hole's event horizon, we can no longer observe it. Does the information vanish? Or does it linger somewhere we cannot see? Some theories suggest that information might be encoded on the event horizon itself, like faint ripples on a surface. Others propose that it escapes slowly through Hawking radiation. The truth remains hidden, wrapped in the silent gravity of the black hole. In this way, black holes challenge our understanding, not just of space, but of knowledge itself. And still, some wonder if they might open doors to deeper places. Fact 39. Wormholes, quiet, maybes. Among the softest and most speculative ideas in physics is the possibility of wormholes. Tunnels through space-time that could connect distant regions of the universe. The mathematics allows them, but nature may not. If they exist, they would require exotic conditions, held open by forms of matter we've never observed. Yet the idea persists, not because we expect shortcuts through the cosmos, but because wormholes help us imagine the flexibility of space-time itself. They represent a quiet curiosity, the dream that the universe may contain hidden pathways, delicate bridges folded within its own fabric. Even if they remain only possibilities, wormholes remind us that the cosmos is full of gentle maybes. And nearby, at the heart of our own galaxy, a giant black hole keeps its steady watch. Fact 40. The gentle giant in the galaxy's heart. At the center of our Milky Way lies a supermassive black hole named Sagittarius A, a calm giant weighing millions of times more than our Sun. Despite its size, it rests in a surprisingly peaceful state, quietly shaping the motions of nearby stars without the roaring activity often seen in other galaxies. Around it, stars orbit in elegant loops, completing their journeys over decades or centuries. This central black hole acts like an anchor for our galaxy, its gravity holding the inner region in a steady, harmonious balance. Though invisible, its presence is felt through the graceful motion of the stars that circle it like glowing dancers. And beyond this silent guardian, other mysteries shine in the form of distant suns. Fact 41. The first stars that ever shone. Long before galaxies took their modern forms, the universe saw its very first stars ignite. These were enormous, bright, and short-lived. Giants made almost entirely of hydrogen and helium. They burned fiercely, flooding the cosmos with light and creating the first heavier elements through their brief but brilliant lives. Though none of these primordial stars remain today, their influence echoes across time. Every atom of carbon in your body, every spark of oxygen in the air carries the legacy of those early suns. They transformed the dark universe into a place filled with warmth, light, and possibility. Their glow marked the beginning of stellar history, and with their birth came questions about the mysteries deep within stars themselves. Fact 42. Hidden hearts of giant stars. Inside every massive star lies a secret, a core where temperatures and pressures reach unimaginable extremes. At these depths, atoms fuse together, releasing energy that supports the star against gravity's inward pull. But even as the star shines with steady light, its inner workings remain hidden from direct view, a quiet forge shaping the elements that fill the universe. These hearts evolve in delicate stages, each layer fusing heavier and heavier elements. From hydrogen to helium, from carbon to iron, the star builds its own intricate structure, like the rings of a cosmic tree. We infer this hidden complexity through models and observations, but the true interior remains a place we can only imagine. Beyond those glowing cores, more subtle puzzles accompany the lives of stars, and the deeper we look, the more mysterious their rhythms become. Fact 43. The puzzles of stellar winds. Even in their quietest moments, stars are never truly still. They constantly release gentle streams of charged particles known as stellar winds. These winds drift outward in all directions, like a soft cosmic breath flowing through space. For some stars, the breeze is mild, barely detectable. For others, especially massive, luminous giants, the winds become powerful rivers of matter. Yet the forces driving these winds remain partly mysterious. Light itself pushes on particles, magnetic fields sculpt their paths, and turbulence deep within the star adds to the flow. Together, these influences weave a complex, shifting pattern that astronomers are still learning to unravel. These winds shape the environments around stars, nurturing nebulae and sculpting space. And intertwined with them are magnetic fields that hum quietly in the dark. Fact 44. Magnetic fields that sing every star, including our own sun, carries a magnetic field, an invisible loop of force that threads through its surface and extends far into space. These fields twist, bend, and sometimes snap, releasing bursts of energy that ripple through the cosmos. Though we cannot hear them, the patterns they create resemble a kind of cosmic music, full of waves and oscillations. Inside stars, these magnetic fields form through churning motions of hot plasma. Their shapes evolve over years and decades, creating cycles of calm and activity. At the surface, they can produce dark sunspots, flares of light, and graceful loops of glowing gas that arc into space. This quiet magnetic song is one of the star's most intricate features, and sometimes it leads to rhythms we can actually observe. Fact 45. The mystery of pulsating suns. Some stars expand and contract in steady cycles, brightening and dimming as their outer layers rise and fall. These pulsating stars act like slow cosmic heartbeats, their luminosity changing over hours, days, or even months. The cause lies in delicate imbalances within their atmospheres, where heat and pressure build up and release in rhythmic patterns. These pulsations help astronomers measure distances across the universe, serving as natural beacons that mark the scale of cosmic space. Yet the full complexity of their inner processes remains partly hidden, shaped by subtle interactions of temperature, density, and radiation. Each pulse is a reminder that even stars follow gentle rhythms. And in some cases, those rhythms can suddenly falter, hinting at deeper mysteries. Fact 46. Sudden stellar fades. Every so often, a star dims without warning, its light dropping in strange, uneven patterns. These fading events can last days, months, or even years, baffling astronomers who try to understand their cause. Some stars may be wrapped in shifting clouds of dust. Others might be surrounded by swirling debris from shattered planets or passing comets. but in many cases, the true reason for the dimming remains unknown. These quiet fades are not violent or chaotic from afar. They resemble a gentle shadow drifting across the star's face, a passing veil whose shape we can only guess. Each dimming is a soft whisper from a distant sun, hinting at unseen structures and evolving worlds. And beyond these fleeting shadows, stars continue their long and luminous journeys. Fact 47. Stars that refuse to die quietly. When massive stars reach the end of their lives, they collapse and explode in supernovae. Brilliant outbursts so bright they can momentarily outshine entire galaxies. Yet even this dramatic ending carries a strange beauty. The explosion disperses heavy elements into space, seeding future stars, planets, and perhaps even life itself. In their final moments, these stars give the cosmos the building blocks for new stories. But not all supernovae behave as predicted. Some flare brighter than expected, while others unfold more slowly or in unusual patterns. A few even fade and brighten again, like cosmic lanterns flickering in the dark. These unpredictable endings remind us that stellar deaths are as varied and mysterious as stellar lives. And from these explosive transitions, something even denser and stranger can emerge. Fact 48. The dust they leave behind. After a star dies, it leaves behind clouds of glittering dust, tiny grains of carbon, silicate, and metal drifting through interstellar space. This dust is incredibly fine, softer than smoke and lighter than breath. Over millions of years, it gathers into nebulae where new stars and planets take shape, recycling the remnants of an older generation into fresh beginnings. The composition of this cosmic dust holds clues to the nature of the star that created it. Some grains are older than our sun, carrying signatures from forgotten stellar ancestors. Others bear the imprint of supernova shockwaves. As they drift, they quietly enrich the galaxy, turning empty regions into nurseries of light. From these gentle motes of dust, new cosmic mysteries begin. And deep within some remnants, stranger structures continue to form. Fact 49. The enigma of neutron star crusts. When a massive star collapses but doesn't quite form a black hole, it becomes a neutron star, an object so dense that a teaspoon of its material would weigh billions of tons. Yet even in this extreme environment, the star has a kind of crust, a thin outer layer where atoms are squeezed so tightly that nuclei arrange themselves in strange geometric patterns. This crust may be the strongest material in the universe, capable of withstanding unimaginable pressures. Beneath it lies a sea of neutrons, swirling and superfluid, flowing without resistance. The boundary between crust and core is one of the most mysterious transitions in astrophysics, hidden beneath layers we can never touch. These dense remnants carry the memory of ancient stars, and some of them spin with astonishing precision. Fact 50. The cosmic clocks that tick too fast. Certain neutron stars, called pulsars, rotate at incredible speeds, some hundreds of times per second. As they spin, beams of radiation sweep across space like the steady flash of a lighthouse. From Earth, these pulses arrive with remarkable regularity, so precise that they can outperform atomic clocks. They tick with the rhythm of a universe that rarely wavers. Yet the source of their stability remains partly mysterious. Their intense magnetic fields, dense interiors, and rapid rotations interplay in ways that scientists are still working to understand. Sometimes a pulsar will suddenly change its pace, skipping a beat, or spinning a little faster in an event called a glitch. These quiet ticks echo across the cosmos like tiny celestial heartbeats. And beyond the remnants of stars, whole new worlds wait in the dark. Fact 51. Worlds that shouldn't exist. Among the thousands of exoplanets discovered, some orbit stars in ways that defy expectations. A few travel so close to their suns that their atmospheres boil away into glowing tails. Others circle dead stars, surviving explosions that should have destroyed them. And some drift in orbits that seem impossibly stable, as though balanced on threads too delicate to remain intact. These unusual worlds challenge our understanding of how planets form and evolve. They suggest that the universe allows for more creativity and resilience than our models predict. Even in environments we once believed too harsh or chaotic, planets can emerge, endure, and surprise us. Each strange world invites us to rethink what is possible, and far beyond, even more exotic planets quietly shine. Fact 52. Planets made of diamond. Among the strangest worlds ever imagined are planets thought to be rich in carbon. So rich, in fact, that under immense pressure, they may form vast layers of crystalline diamond. These so-called diamond planets orbit their stars in tight, scorching paths where heat and pressure help sculpt their glittering interiors. From afar, they would not sparkle like gemstones. Instead, they would appear dark, heavy, and quietly radiant with internal warmth. These planets remind us that worlds can form under wildly different conditions. While Earth grew from silicates, metals, and water, these exotic neighbors are forged from carbon-rich beginnings that lead to entirely different landscapes and possibilities. In the quiet of deep space, even diamond worlds turn gently through starlight. And closer to their suns, stranger giants drift even faster. Fact 53. Hot Jupiters, hugging their suns. Hot Jupiters are enormous gas planets that orbit incredibly close to their stars, sometimes completing a full orbit in just a few days. Their atmospheres boil under intense heat, swirling with winds faster than any hurricane on Earth. Despite their size, they cling tightly to their parent stars, their day sides glowing like soft embers against the darkness. What makes them mysterious is how they arrived in such tight orbits. No model suggests they could have formed so close to their stars. Instead, they likely migrated inward over time, drawn by gravitational interactions we don't yet fully understand. Their existence challenges our ideas of planetary formation, showing that solar systems are far more flexible than we once imagined. And while these giants cling to their suns, others drift alone through the dark. Fact 54. Rogue worlds. Drifting alone. Not every planet belongs to a star. Some worlds wander freely through space, unanchored and unlit, moving like silent travelers through the cosmic night. These rogue planets may have been flung from their original systems or formed in isolation, their journeys shaped only by gravity's occasional pull. Without a star to warm them, they grow cold and still, shrouded in deep, eternal twilight. Yet, even in this darkness, some may retain internal heat, harboring oceans beneath thick shells of ice. Others may simply drift, quiet and unchanging, for billions of years. They are reminders that the universe holds stories not bound to suns or orbits, stories of solitude, resilience, and quiet endurance. And beyond these lonely travelers, even stranger moons begin to gather around distant giants. Fact 55. Moons, larger than planets. In distant star systems, astronomers have found hints of moons so large that they rival and even exceed the size of small planets. These supermoons, if confirmed, would orbit gas giants much bigger than Jupiter, creating miniature solar systems within solar systems. Their surfaces might host towering mountains, hidden oceans, or swirling atmospheres shaped by the constant tug of their enormous parent worlds. Such moons challenge our expectations of what a moon can be. They blur the line between moon and planet, showing that worlds can form in nested layers of complexity. If life ever arose on one of these giants, it would see its sky filled by the glowing face of a massive planet rising and setting. These oversized moons deepen our sense of wonder, and around other stars, planets themselves sometimes glow. Fact 56. Atmospheres that shine. Some exoplanets have atmospheres so hot that they shimmer with faint, eerie light. Temperatures can rise high enough for metals to vaporize and drift through the air as glowing clouds. On certain worlds, winds whip these metallic vapors around the planet, creating shifting bands of brightness that ebb and flow like slow ocean tides. Others shine because their atmospheres reflect starlight unusually well, turning them into pale, ghostly orbs that appear brighter than expected. These glowing atmospheres reveal themselves in careful measurements, tiny dips in starlight, subtle shifts in color, gentle hints of exotic chemistry. Even in darkness, some planets carry their own quiet luminescence, and yet, not all worlds follow the expected script of water and air. Fact 57. The mystery of missing water. Water is common throughout the cosmos, in comets, icy moons, and interstellar clouds. Yet some exoplanets that should be rich in water reveal surprisingly dry atmospheres. Even worlds forming in watery regions sometimes lose their moisture to intense heat, fierce solar winds, or processes we don't yet fully understand. These unexpectedly dry planets force astronomers to rethink how water behaves under different conditions. Perhaps it hides beneath thick crusts, or escapes into space over millions of years, or never accumulates at all due to subtle quirks in planetary chemistry. The absence of water raises as many questions as its presence. And beyond these parched worlds, some planets race around their stars with astonishing speed. Fact 58. Planets that orbit in minutes. Some of the most astonishing exoplanets slip around their stars in mere hours, completing an entire year in less time than it takes us to make breakfast. These ultra-short period planets skim so close to their stars that the starlight reshapes them, stretching their surfaces and heating them until rocks may melt into shimmering vapors. Their tight, swift orbits challenge our understanding of planetary survival. How can a world endure such heat, such gravitational stress, such unending proximity? Yet somehow, these planets persist, racing around their stars in a steady, quiet rhythm. From a distance, their motion feels less frantic and more like the delicate ticking of a cosmic clock. And beyond these whirling worlds lie planets that seem far too large for their small sizes. Fact 59. The riddle of super-Earths. Super-Earths are planets larger than our own, but smaller than Neptune, a category that doesn't exist in our solar system, making them feel both familiar and alien. Some are rocky giants with thick atmospheres. Others may be water worlds with oceans hundreds of kilometers deep. Their diversity defies simple explanation, suggesting that planetary formation can follow many more paths than we once imagined. Why do some stars host several super-Earths, while ours has none? Why do some appear hot, compact, and dry, while others are cloaked in misty layers of gas? Each discovery adds to the puzzle, revealing new combinations of temperature, composition, and structure. These worlds broaden our sense of what a planet can be, and among them, some drift quietly in regions where life might softly take hold. Fact 60. Goldilocks. Zones in unexpected places. The Goldilocks zone, the region around a star where temperatures allow liquid water, is often pictured as a neat band at a comfortable distance. But in the wider universe, warmth can come from many sources. On some icy moons, tidal forces from giant planets create internal heat, keeping oceans liquid beneath frozen crusts far from starlight. Elsewhere, dim red dwarfs provide gentle but long-lasting warmth, creating habitable zones far closer than we would expect. These unexpected pockets of possibility show that life-friendly conditions may exist in surprising places. Not every cradle of habitability depends on sunshine. Some may glow from within, warmed by subtle forces and sheltered beneath protective layers. And beyond these quiet oases, whole galaxies drift with mysteries of their own. Fact 61. Galaxies that look like ghosts. Some galaxies drift through the universe with barely any stars at all. Their shapes faint and delicate, like cosmic phantoms. These ultra-diffuse galaxies are so dim that they almost blend into the background darkness. Their starlight spread thinly across enormous distances. From afar, they resemble barely visible smudges, vast in size, yet whisper light in brightness. What makes them so elusive remains a puzzle. Some may have lost their gas early on, unable to form the stars that would have brightened their glow. Others might have been stretched by gravitational tides, their contents pulled apart until only a pale shadow remained. They float quietly through the night, reminders that not every galaxy burns with radiant fire, and among these ghosts, some grow old before their time. Fact 62. Ancient giants. Too mature for their age. Occasionally, astronomers find galaxies that appear far too developed for the early universe. Massive systems with older stars, assembled long before cosmic history should have allowed it. These ancient giants challenge our theories of how quickly galaxies can grow. Their stars shine with the warm, aged light of systems that should have taken billions of years to form, and yet they appear very close to the universe's beginning. How did these galaxies mature so quickly? Did they gather material at an extraordinary pace? Did they merge in rapid bursts, stacking stellar generations one atop another? Or do they hint at processes we have not yet uncovered? Their quiet maturity adds a gentle wrinkle to our understanding of cosmic time. And stretching outward from them, long trails of starlight tell stories of motion and memory. Fact 63. Stellar streams. Stretching for light years. Around many galaxies, including our own, long ribbons of stars stretch across the darkness, like delicate cosmic brushstrokes. These stellar streams are the remnants of smaller galaxies or star clusters that venture too close to larger neighbors. Over millions of years, gravity pulls them apart, leaving behind graceful arcs of light that wrap around the host galaxy. These streams act as living records of past encounters, the soft footprints of cosmic interactions. They reveal how galaxies merge, grow, and reshape one another. Though barely visible, they weave elegant patterns across the sky, as though the universe itself is painting with stars. Each stream carries the memory of a once cohesive world, and deeper in the galaxy's heart, stranger shapes continue to emerge. Fact 64. The mystery of ultra-diffuse galaxies. Ultra-diffuse galaxies look almost like illusions, large as the Milky Way, yet containing only a sprinkling of stars. Their vast expanses appear empty, as though someone stretched a small galaxy into an enormous shape and left the spaces hollow. Some of these ghostly structures are held together by unusually massive dark matter halos, giving them strength despite their fragile appearance. Others, strangely, seem to lack dark matter altogether. Their origins remain uncertain. Did they form this way, quietly and sparsely? Or did they once shine brighter, only to have their content stripped away by gravitational tides? These galaxies drift like faint smudges in the cosmic night, offering only hints of their true stories. And out beyond these dim giants, galaxies often reshape themselves through gentle cosmic collisions. Fact 65. Collisions that build new worlds. Though galaxy collisions sound dramatic, they unfold over billions of years. Slow, graceful interactions that pass like deep breaths in cosmic time. When two galaxies meet, their stars rarely collide directly. Instead, their combined gravity stirs gas clouds, lights new star formation, and gently reshapes their structures. The result can be beautiful. Long tidal tails, shimmering bridges of starlight, and blooming clusters born from the interaction. These mergers help galaxies grow, recycle their material, and evolve into new forms. The Milky Way itself will someday merge with the Andromeda Galaxy, creating a serene new system with a blended heart. Nothing sudden, nothing catastrophic, just a patient dance guided by gravity. And within these flowing shapes, some galaxies lose their centers altogether. Fact 66. Spirals without centers. A small number of galaxies defy the familiar pattern of spirals anchored by bright central bulges. These rare, bulgeless spirals spread their arms without a luminous core, giving them a strangely airy, open appearance. Their stars rotate smoothly, but no dense cluster marks the center, only a gentle continuation of their swirling disk. Why these galaxies lack central bulges remains a quiet puzzle. Perhaps they avoided major mergers that usually build bright cores. Perhaps their internal processes shaped them differently from birth. Whatever the cause, their structure is serene and elegant, like a spiral drawn with a soft hand. These centerless spirals remind us that even common shapes can hide uncommon stories. And farther out, some galaxies reveal something even more surprising: the absence of dark matter itself. Fact 67. Galaxies with no dark matter. Most galaxies depend on dark matter to hold their stars together, but a few rare systems appear to lack it almost entirely. These galaxies move and rotate in ways that can be explained solely by their visible matter, a surprising contrast to the usual cosmic pattern. Without dark matter's invisible embrace, their stars drift more loosely, forming delicate shapes that seem unusually fragile. How such galaxies form remains a mystery. Some may have lost their dark matter through past interactions, reshaped by gravitational tides from larger neighbors. Others might have formed under unusual conditions, never gathering the invisible mass that most galaxies rely upon. Their existence challenges long-held assumptions, reminding us that the universe often writes exceptions into its rules. And from these gentle anomalies, even emptier regions stretch outward. Fact 68. The empty hearts of ellipticals. Elliptical galaxies often look like smooth, glowing ovals, their stars scattered in broad, rounded shapes without the distinct arms seen in spirals. Yet many of them hide hollow centers, vast regions near their cores, where surprisingly few stars reside. These cores may have been carved out by the slow dance of supermassive black holes merging and stirring the central stars away. These empty hearts give ellipticals a serene, understated beauty. Their light softens toward the center instead of brightening, creating a quiet gradient of starlight. In their emptiness lies a gentle sense of history, echoes of ancient interactions that emptied out their cores long ago. And stretching between these giant systems, faint bridges of stars quietly form. Fact 69. The bridges between galaxies. When galaxies pass near one another, gravity can draw out thin streams of stars, dust, and gas, forming delicate bridges that connect the two systems. These luminous pathways are like soft threads woven between distant islands, carrying the signatures of past encounters. Some bridges stretch for hundreds of thousands of light years, barely visible, but rich with clues about the galaxies involved. Through these connections, galaxies exchange material, fuel new star formation, and sometimes even share clusters of stars. Each bridge is a reminder that galaxies are not isolated structures, but part of a vast, interactive cosmic web. Their gentle arcs trace the motion of gravity across unimaginable distances. And beyond these delicate threads lies one of the largest mysteries of all, a cosmic wall too vast to fully comprehend. Fact 70. A wall of galaxies we cannot explain. In the far reaches of the universe, astronomers have discovered enormous structures, vast walls made of thousands of galaxies stretching across billions of light years. One of these, known simply as a galactic wall, is so immense that it challenges our understanding of how the universe forms large-scale structures. According to current theories, objects of this size shouldn't have had time to grow in the age of the cosmos, and yet there they stand, quiet and ancient. These cosmic walls are not solid, but rather immense patterns in the distribution of galaxies, like gentle ripples frozen into space. Their sheer scale invites wonder, revealing a universe that builds far larger shapes than our models predict. And from these vast constructs, smaller, stranger signals flicker across the dark. Fact 71. Fast radio. Bursts in the dark. Fast radio bursts, or FRBs, are sudden, millisecond-long flashes of radio energy coming from distant corners of the universe. They appear without warning, with no clear pattern, like brief sparks echoing through cosmic silence. Some repeat, sending soft pulses months or years apart, while others flare only once and never speak again. Despite their power, they last so briefly that tracking them to their origins is incredibly difficult. They may come from neutron stars, magnetars, or processes we haven't yet imagined. Each burst is like a quick, celestial heartbeat, bright, mysterious, and gone before we fully grasp it. Their fleeting nature keeps astronomers listening closely, and in the realm of cosmic flashes, even stranger bursts appear from time to time. Fact 72. Gamma flashes that arrive too soon. Gamma-ray bursts are among the most powerful explosions in the universe, releasing more energy in a few seconds than our sun will emit in its entire lifetime. Most come from collapsing massive stars or merging neutron stars, events so intense they can be seen across billions of light years. Yet some gamma flashes behave in ways that don't match any known category, arriving too early, lasting too briefly, or shining in colors we don't expect. These puzzling bursts challenge our understanding of extreme physics. They may hint at exotic processes deep within stellar cores, or at interactions taking place in the thin outskirts of galaxies. Even their timing, sometimes slightly off from predictions, stirs quiet questions about what triggers them. Each unexplained flash is a soft reminder that the universe still holds countless surprises, and beyond these bursts, Even subtler particles drift quietly through space. Fact 73. Neutrinos from nowhere. Neutrinos are some of the universe's most elusive travelers. Tiny particles that pass through matter as though it isn't there at all. Trillions of them drift through your body every second, silent and unhindered, born from stars, supernovae, and distant cosmic events. Yet occasionally, detectors on Earth capture neutrinos with energy so high and so unusual that their origins defy explanation. These cosmic neutrinos seem to come from nowhere in particular, arriving with trajectories that don't point back to obvious sources. They hint at processes occurring in deep, hidden regions of the cosmos, perhaps near black holes, or in environments we haven't yet imagined. Their paths are quiet clues, scattered like whispers from unseen corners of space. And beyond the neutrino's silence lies a mystery defined not by signals, but by their absence. Fact 74. The Great Silence of Space. For decades, astronomers have listened for signs of life. Radio signals, unusual patterns, anything that might suggest another civilization reaching back. Yet the universe remains overwhelmingly quiet. This profound stillness is known as the Great Silence, and it poses a gentle question. In a cosmos filled with billions of worlds, why have we heard nothing? The silence isn't ominous, it's contemplative. Perhaps life is rare, or spread thinly across time. Perhaps civilizations grow inward, exploring thought more than space. Or maybe the signals drift in frequencies we've yet to understand. In this vast quiet, the unknown feels soft rather than lonely, like a library filled with books still waiting to be opened. And hidden within that stillness, even galaxies seem to align in ways that puzzle us. Fact 75. The curious alignment of quasars. Quasars are brilliant beacons powered by supermassive black holes, shining from the farthest reaches of the universe. But when astronomers examine their polarization, the direction in which their light waves vibrate, they found something unexpected. Across enormous distances, clusters of quasars seem to align with one another, their light organized as though following a subtle cosmic pattern. This alignment stretches across billions of light years, too vast for any known structure or influence to explain. It's as if quasars, separated by unimaginable gulfs, still share a quiet connection, like distant lanterns flickering in the same breeze. Such large-scale coherence challenges our understanding of cosmic randomness. And beyond these aligned lights, even the ancient background glow carries quiet secrets. Fact 76. The dip in the cosmic microwave background. The cosmic microwave background, the universe's oldest light, is mostly smooth and even, like a soft glow spread across the sky. But within this ancient light sits a subtle dip, a slightly cooler patch that doesn't quite match predictions. It's not dramatic, just a faint, quiet deviation, but its presence hints that something unusual shaped the early universe. Some suggest this small, cool region could be the imprint of a massive structure, bending light on its journey to us. Others imagine it might be a relic of early cosmic processes we don't yet understand. Though the dip itself is gentle, its implications run deep, stirring questions about the forces that sculpted the universe's earliest moments. And nearby lies a region even colder, wrapped in deeper mystery. Fact 77. The cold spot. Mystery. Among the map of ancient light sits the cold spot, a large area that appears significantly cooler than its surroundings. Its existence challenges expectations, as no simple process seems able to create such a wide, quiet depression in temperature. Some theories suggest a vast cosmic void, an enormous region of space with fewer galaxies, might create the effect by stretching passing light. Others propose ideas more exotic: early universe anomalies, subtle variations in inflation, or processes we have yet to imagine. Despite countless studies, the cold spot remains gently unresolved, a soft bruise on the sky whose cause eludes our understanding. Its cool glow invites contemplation, a reminder that even the oldest light holds surprises. And drifting through that ancient glow are particles far stranger still. Fact 78. Ghost particles passing through us. Every moment, countless neutrinos, often called ghost particles, pass through your body without leaving a trace. These tiny travelers rarely interact with matter, gliding through planets, stars, and even galaxies as though they were made of mist. Most neutrinos come from the sun or from cosmic rays striking the atmosphere, but some originate in far more mysterious places. High-energy neutrinos, detected on Earth, sometimes seem to arrive from empty regions of sky, lacking any obvious cosmic source. Their origins could lie in distant black holes, turbulent galactic cores, or exotic events we have yet to understand. Each one is like a message carried through the universe, silent and nearly undetectable. These ghostly particles remind us that the cosmos communicates in faint and subtle ways. And among those signals, some of the strongest come from stars with magnetic hearts. Fact 79. Magnetaires and their quiet power. Magnetaires are among the most extreme objects in the cosmos. Neutron stars wrapped in magnetic fields so powerful that they can twist the very fabric of atoms. Yet from a distance, they appear calm, spinning slowly with a muted glow. Their magnetic fields are trillions of times stronger than Earth's, strong enough to reshape particles and influence light in subtle, mesmerizing ways. Occasionally, a magnetar releases a burst of energy, a soft flare, or a sudden flash that can travel across galaxies. But most of the time, they remain quiet guardians of intense forces, holding their power in serene stillness. Their surface may shift and crack under the tension of their own magnetism, producing gentle starquakes that ripple through space as faint signals. These magnetic giants remind us that calm appearances can hide extraordinary strength, and in the universe's rhythms, other patterns whisper through the darkness. Fact 80. The puzzling rhythm of the universe. Across vast spans of space and time, certain cosmic events seem to repeat with quiet regularity. Some quasars flicker in patterns too steady to be random. Certain fast radio bursts pulse with surprising consistency, as though following a hidden metronome. Even galaxies themselves sometimes rotate in ways that hint at gentle, repeating cycles. These rhythms challenge our expectations of chaos and randomness. They suggest that beneath the universe's complexity, subtle structures and harmonies may be at play. The causes remain uncertain. Gravity, magnetic fields, or even processes we have yet to recognize could be shaping these cosmic patterns. Whatever their origin, these rhythms feel like the universe breathing softly, keeping time across the void. And from these gentle cycles, imagination drifts toward even larger possibilities. Fact 81. Multiverses beyond our view. The idea of a multiverse suggests that our universe may be just one of many, a single bubble floating among countless others, each with its own laws, histories, and cosmic landscapes. Though purely theoretical, the concept arises naturally from several models of physics, whispering the possibility that reality stretches far beyond what we can see. If other universes exist, they may be unreachable forever, separated by distances or barriers we cannot cross. Yet their presence could subtly influence our own cosmos, shaping its constants or providing context for its mysteries. Even without direct evidence, the multiverse idea invites a gentle sense of wonder. The thought that creation might be broader than anything we can imagine. It opens the mind softly, like a window onto a wider dream. And beyond that dream, even stranger possibilities begin to unfold. Fact 82. Dimensions we cannot touch. Our familiar world unfolds in 3 dimensions of space and 1 of time. Yet some theories whisper that reality may contain hidden dimensions curled so tightly we cannot perceive them. These extra dimensions might be woven into the fabric of space like delicate threads, shaping gravity, particles, and the birth of the universe in ways we only dimly sense. If they exist, these hidden dimensions are not places we could visit. Instead, they are quiet structures that underlie all motion and matter. They might guide the paths of particles, influence the strength of forces, or provide room for the universe's earliest energies to unfold. Though invisible, these dimensions offer a soft reminder that reality may be richer than its surface suggests. And from this richness grows the possibility of space folding back upon itself. Fact 83. Space that loops back on itself. Some cosmological models propose that space might not stretch infinitely outward, but instead curve in such a way that traveling far enough in one direction could bring you back to where you began. This idea paints the universe as a gentle loop, not a simple circle, but a complex, multidimensional shape that folds back upon itself like a cosmic ribbon. We cannot yet tell whether our universe has this kind of topology. Its size may be too vast, its curvature too subtle for our instruments to detect. But the possibility remains, quiet and elegant, that the cosmos could be both boundless and finite, with no true edges or endpoints. In such a universe, every journey would be part of a larger, seamless whole. And nestled within these speculations lies a question as old as wonder itself. Fact 84. The simulation question. A quiet thought sometimes drifts through scientific and philosophical circles. What if our universe behaves with such orderly laws because it is in some way a simulation? The idea isn't about computers or screens, but about whether the fabric of reality might have an underlying informational structure, a kind of mathematical code that governs all things. This notion is not a conclusion, only a curiosity. It arises because the universe often behaves with remarkable precision, as though following a set of elegant instructions. Whether that reflects deep physical truths or simply the nature of our mathematics is unknown. The simulation question doesn't diminish the beauty of the cosmos. Instead, it highlights how mysterious and coherent it is. And it gently leads us toward questions of time before time. Fact 85. Time before time. We often imagine the universe beginning at a single moment, the Big Bang, when time and space unfurled together. But some theories suggest there may have been something before this moment, not a time as we understand it, but a different state altogether, where the familiar rules didn't yet apply. In this view, the Big Bang wasn't a beginning, but a transition. This earlier phase might have been timeless, a quiet field of potential waiting to unfold. Or it might have been another universe contracting, giving birth to ours in a gentle bounce. Though we may never witness these possibilities directly, they offer a serene comfort that the cosmos may be part of a larger, continuous story. And out of that earliest state, tiny fluctuations began to shimmer. Fact 86. Quantum fluctuations that sparked it all at the smallest scales. Even emptiness is alive with motion. Quantum fluctuations, tiny shifts in energy that flicker in and out of existence, may have played a crucial role in shaping the young universe. During the brief, rapid expansion known as inflation, these tiny ripples were stretched across vast distances, seeding the patterns that would later form galaxies and clusters. It's astonishing to think that grand cosmic structures, billions of light years long, may trace their origins to delicate quantum tremors smaller than atoms. These fluctuations were subtle and quiet, yet they helped determine the universe's large-scale shape, guiding matter into the filaments and voids we observe today. In their gentle randomness, the universe found its earliest structure, and even now, subtle energies continue to hum within empty space. Fact 87. Vacuum energy's secret. The vacuum of space might seem like a perfect void, but it carries a faint, persistent energy, a quiet presence woven through the fabric of existence. This vacuum energy could be related to dark energy, the mysterious force driving the universe's accelerating expansion. Yet its value remains one of the greatest puzzles in physics. Calculations predict it should be far larger than what we observe, by staggering amounts. Why does the vacuum hold just the right amount of energy to influence the cosmos so gently? Why not more, or less, or none at all? This delicate balance shapes the universe's fate, guiding its expansion with a soft but steady hand. The secret of vacuum energy remains hidden in silence, inviting continual curiosity. And from these mysteries arises an even more imaginative possibility. Fact 88. The possibility of cosmic consciousness. Some thinkers quietly wonder whether the universe might possess forms of organization or awareness far beyond our imagination. This idea doesn't imply a mind in the human sense, but rather that consciousness could emerge in complex systems, perhaps even on cosmic scales. Galaxies, networks of stars, or patterns of dark matter might hold subtle properties we haven't yet learned to detect. Though speculative, the thought invites a peaceful sense of wonder. That awareness might not be limited to biological brains. Instead, it could be a natural outcome of complexity, woven into the very structure of the cosmos. Whether or not this idea holds truth, it encourages us to see the universe as something inherently connected, layered, and alive with possibility. And from that sense of connection, another idea gently follows. Fact 89. A universe that learns. Some theories imagine the universe as a kind of evolving system, one that learns over time through the outcomes of physical processes. This doesn't mean intention or purpose, but rather that natural laws could shift slightly with each cosmic generation, selecting for stable configurations that endure. In this view, universes might arise with different constants, and those that allow stars and structures to form persist, while others fade quietly away. Such ideas belong to the realm of deep speculation, but they offer a serene perspective that the universe may not be static, but part of a grand, unfolding story in which patterns refine themselves across eons. This gentle evolution could help explain why our cosmos is so finely balanced for complexity. And from evolving patterns, the mind turns toward the shapes we think we see. Fact 90. Patterns we only think we see. The human mind is a master of pattern finding. When we look into the cosmos, we often notice shapes and alignments that feel meaningful. But sometimes these patterns are illusions born from chance. Stars align by accident, galaxies cluster in ways that mimic design, and cosmic structures can appear ordered simply because our perception seeks harmony. Yet these imagined patterns have value too. They inspire curiosity, guiding our questions and shaping our desire to understand the universe more deeply. Even when a pattern proves to be coincidence, the act of searching reveals new insights and unexpected beauty. And beyond our interpretations lies the quiet unfolding of the universe's distant future. Fact 91. Stars that have yet to form. Even as the universe expands and ages, vast clouds of gas and dust continue drifting through galaxies, waiting for gentle nudges of gravity to draw them inward. Within these clouds, some spanning hundreds of light years, lie countless potential stars, curled like seeds in the soil of space. Over millions of years, these clouds will slowly contract, warming as they shrink, until new stars finally ignite in soft golden light. Many of the stars that will one day shine in the Milky Way have not yet taken shape. They rest quietly in the dark, wrapped in cool, velvety clouds that cradle their future glow. These unborn suns remind us that the cosmos is always becoming, always renewing itself. And beyond these timid beginnings, galaxies themselves continue their slow transformations. Fact 92. The slow drift of galaxies. Galaxies move through space with calm persistence, drifting along the currents of the cosmic web. Some race toward one another, pulled by gravity into ancient dances of merging and reshaping. Others drift apart as dark energy stretches the fabric of space between them. Their motions are graceful and unhurried, unfolding over billions of years, a choreography so slow that only the universe itself can witness the full performance. Our own Milky Way is on a quiet journey toward the Andromeda Galaxy, inching closer at a pace more subtle than the growth of a tree. In the deep future, they will combine into a single, majestic system. But for now, they glide toward each other in tranquil anticipation. As galaxies drift, the light within them ages, leaving only soft traces behind. Fact 93. The fading of starlight. As time stretches onward, stars gradually exhaust their fuel, one by one. The bright hot stars fade first, leaving behind cooler, gentler suns that glow with warm, steady light. Eventually, even these long-lived stars will dim, entering quiet stages where their glow softens into red embers before fading entirely. This slow dimming is not abrupt or sorrowful. It is a natural part of cosmic time, a peaceful transition as the universe cools and its luminous energy disperses. Future galaxies will appear softer, their brilliance muted, their outlines blurred like distant lanterns in the fog. In the fading shimmer of starlight, the universe leans gently toward the calm darkness ahead. And beyond that dim horizon, even deeper mysteries await. Fact 94. A sky growing colder. As billions of years drift by, the universe continues to expand, and with that expansion comes a gradual cooling. The cosmic microwave background, once warm enough to glow like soft fire, has already faded into a near-frozen whisper. In the far future, it will cool even more, sinking toward absolute stillness. Stars will stand farther apart, their light taking longer to cross the widening distances. The night sky will grow quieter, dimmer, and colder, not through any sudden change, but through the gentle stretching of time. Space becomes a vast, tranquil ocean of cool darkness, punctuated only by the soft glow of the few stars still burning. This growing calm marks the universe's slow drift into deeper silence. And within that silence, one final kind of star-like remnant will endure. Fact 95. the last black hole. Long after the last stars have faded, black holes will remain as the universe's most enduring structures. They will sit quietly in the dark, slowly evaporating through Hawking radiation, a process so gentle that even the largest black holes will take unimaginable stretches of time to disappear. For ages beyond comprehension, they will glow faintly, not with starlight, but with the softest emission a black hole can release. These final embers of the cosmos, fading so slowly, will mark the closing chapters of cosmic history. Their evaporation is peaceful, a long unwinding of gravitational energy into the quiet fabric of space. Eventually, they too will vanish, leaving behind only the vast emptiness of cooling expansion. And as these giants fade, light itself will encounter new limits. Fact 96. When light can no longer travel. In the deep future, when the universe has stretched so far that galaxies lie beyond any reachable distance, even light will lose its ability to cross the widening void. Photons traveling between remote regions will be stretched until their energy dwindles toward nothing, like waves drawn thin across an endless shore. Over trillions upon trillions of years, the fabric of space will become so wide that communication, heat, and motion fade into stillness. This quieting of light does not come with drama, only a gentle dimming, a long settling into cosmic twilight. The universe, once bright with the fire of creation, will soften into a tranquil, whispered hush, and even after light can no longer travel freely, the cosmos will still hold its final secrets. Fact 97. The echo of the universe's final breath. Even as the cosmos drifts toward stillness, faint traces of its earliest moments linger like soft echoes. Tiny particles, low-energy photons, and delicate gravitational murmurs continue to ripple across space. These remnants carry information about everything the universe has ever been. Each quiet vibration, a memory of stars long extinguished and galaxies long dissolved. In this distant era, space will feel calm and almost timeless. But the whispers of the past will remain, preserved in patterns too subtle for any observer to witness. The universe will hold its history gently, like a deep breath that never fully fades, even as silence settles into every corner. This lingering echo marks the final transition into the universe's last phases. And beyond that hush, time itself begins to change. Fact 98. A future without time. As the universe cools and expands, processes that once shaped reality will slow to a near standstill. Motion weakens, energy thins. Interactions that once happened in fractions of seconds begin to take trillions of years. In such a state, time loses its familiar meaning. Without change, without progression, the flow of time becomes indistinguishable from stillness. Physicists sometimes describe this era as the heat death, but from a cosmic distance, it feels more like a gentle dimming, a quiet evening settling over all existence. Time itself will stretch into an almost motionless continuum, where the distinction between moments softens until it feels like there is only one long, peaceful now. And from that endless calm, only the faintest flickers of energy remain. Fact N-99, the last whisper of energy. Even in an unimaginably distant future, tiny bursts of energy will continue to appear through quantum fluctuations, brief, delicate sparks flickering into existence and then dissolving back into the void. These fluctuations will not warm the universe or illuminate the dark, but they will add the softest shimmer to the otherwise perfect stillness of space. This final whisper of energy ensures that the cosmos is never truly empty. Even at the edge of eternity, creation continues in miniature, like faint breaths in a sleeping giant. Each quantum flicker is a reminder that the universe, even in its quietest moments, never fully stops. And beyond these final sparks lies one lingering mystery, the question that endures when all others fall silent. Fact 100. The mystery that will always remain. In the end, after stars fade and galaxies drift into silence, one question lingers like a soft glow in the dark. Why does the universe exist at all? Even with all our discoveries, all our careful measurements, the deepest truth remains just beyond our grasp. The cosmos expands, evolves, cools, and quiets, yet the reason behind its beginning, its laws, and its breathtaking beauty remains hidden, a mystery that hums beneath everything. Perhaps the question itself is part of the universe's design, encouraging curiosity across generations of stars and minds. Or perhaps the answer is woven into the fabric of existence in ways we'll never fully see. Whatever the case, the mystery endures, gentle and everlasting. And in that enduring wonder, the universe feels infinite once more. And as our journey comes to a gentle close, I hope you found a bit of calm among the stars tonight. If you enjoyed drifting through these sleepy facts, don't forget to like the video, subscribe, and comment below what topic you'd love to fall asleep to next. When you're ready to keep dreaming, tap the end screen to watch the next Sleepy Astronaut video and continue your quiet voyage through the universe. Sweet dreams, and see you among the stars.